In this video, we continue our study of limits. We will begin by looking at a graphical and intuitive approach to this concept. Next, we will introduce what are called discontinuities. And finally, we will look at the formal definition of the limit. I do believe that the best way to get an initial understanding of limits is to use graphs. So that's what we have here. We have the graph of a very basic function. Here we have f of x is equal to x plus 3. Now you are probably very aware that for a function like this, it will be defined for all values of x. And right here at x equals 3, the function is defined as 6. In other words, f of 3 is 6. However, we are not now going to be so interested in what the definition of the function is at x equals 3, but rather how does the function behave as we get close to x equals 3. We can have x values approach 3 from the left, in which case then we notice that the corresponding f of x values will approach 6. And we can get f of x to be as close to 6 as we want by choosing x to be as close to 3 as we need to have it. So this is called the left-hand limit. And look at the notation here. It says that the limit of this function x plus 3 as x approaches 3 from the left, very important, this little minus sign is saying that it's approaching 3 from the left. This limit is equal to 6. Values of x can also approach 3 from the right. If you observe carefully, you can see that as x gets closer and closer to 3, f of x is also getting closer and closer to 6. What we have here is called the right-hand limit. The limit of this function as x approaches 3 from the right is equal to 6. In other words, you can get f of x to be as close to 6 as you want by choosing an appropriately close enough value for x. In this case, since both the left-hand limit and the right-hand limit exist and are equal, we say that the limit exists. And that limit is going to be equal to 6. Now in this case, it also so happens that the function is defined at x equals 3 as 6. And so we have that the limit of the function as x approaches 3, notice now we don't say whether from the left or from the right. This is just saying that the limit as x approaches 3 is going to be equal to f of 3. This will not always be the case. So just recapping what we have said here, the left-hand limit is equal to 6, the right-hand limit is equal to 6, therefore the limit is equal to 6. Here we have a function whose graph is very similar to the one we looked at just now, with one notable exception. This function is not defined for x equals 3. So on this graph, at x equals 3, if we come up to the line, we have a hollow circle. If we were to inspect points along this line, we would see that as the x-coordinate gets closer and closer to 3, the y-coordinate gets closer and closer to 6. Remember, the y-coordinate represents f of x. Likewise over here, as the x-coordinate gets closer and closer to 3, the y-coordinate gets closer and closer to 6. So what that means is that both the left hand and the right hand limits exist and are equal to 6. The limit of this function as x approaches 3 is 6. However, the function is not defined for x equals 3. f of 3 has no meaning. So what we have here is a discontinuity. And this type of discontinuity is often referred to as a point discontinuity. Now you have some books that refer to this as a whole discontinuity, and I think that's quite okay. So we've looked at our first discontinuity and notice that here with this discontinuity, the function is not defined. However, the limit does exist for x equals 3. Once again, we have a function that is similar to the previous one. The graph of this function is a straight line with a hollow circle right at this point. However, unlike the previous case, this function is defined for x equals 3, and it is defined as being equal to 7. So don't confuse these two issues now. The definition of the function at a certain point and the limit of that function as x approaches some particular value of x. If we were to move along this line, we see that as the x-coordinate gets closer and closer to 3, approaching from the left, f of x gets closer and closer to 6. As we come from this side, as the x-coordinate gets closer and closer to 3, f of x is getting closer and closer to 6. So the limit does exist, and as the function approaches 3, that limit is equal to 6. However, the function in this case is defined as 7. In other words, f of 3 is 7. This type of discontinuity here is the same type as we looked at just now. It's a point discontinuity. So I hope you're beginning to see the difference between the limit of a function as x approaches some value c, let's say, in this case c would be 3, and f of c, the definition of that function, when x is equal to a particular value. So you could have for x equal 3 that the function is not defined, or that it is defined as 7 or 11 or a million or minus 100 or minus 1,000. The point is that in a case like this, the limit of the function as x approaches 3 would be 6. So I hope this is becoming clear. Here we have what is called a piecewise function. For values of x less than 3, the function is x squared. For values of x greater than 3, the function is x plus 10. For x equal to 3, the function is defined as 5. So this function is defined here. Let's take a look at the limit of this function as x approaches 3. If we come on the left here, and we come up to this line, we find that as we go increasing the value of x, in other words, we increase the value of the x-coordinate, getting it closer and closer to 3, we find that the y-coordinate gets closer and closer to 9. If we come over to the right, that would bring us way up here, and we now go making the x-coordinate of points along this line closer and closer to 3, we find that the y-coordinate gets closer and closer to 13. So we have that the limit as x approaches 3 from the left is 9, the limit as x approaches 3 from the right is 13, therefore the limit as x approaches 3 for this particular function does not exist, because for the limit to exist, the left-hand limit has to exist, the right-hand limit has to exist, and they both have to be equal. Note in this case that even though the limit at x as x approaches 3 does not exist, the function is defined for x equal 3. f of 3 is 5. This type of discontinuity is referred to as a gap discontinuity. Where you have a gap discontinuity, the function may or may not be defined. It so happens that in this case the function is defined. f of 3 is 5. Now let's turn our attention to this function. You should readily see that this function is not going to be defined for x equal to 3. Let's take a look at the limit. If I approach from the left and I look at x-coordinates that get closer and closer to 3, what happens to the y-coordinate? The y-coordinate simply grows without bound, but in a negative direction. Let's come over to the right of x equal 3. I come up here and I look at the x-coordinate of points along this line. As those x-coordinates get closer and closer to 3, the y-coordinate grows without bound. So neither the left nor the right limits technically exist. However, we are accustomed to writing this out this way. We say that the limit for this function as x approaches 3 from the left is negative infinity. Just remember that infinity is undefined. Likewise, as we approach from the right, the limit of this function, as we approach 3 from the right, the limit of this function is plus infinity. So obviously, the limit of this function as x approaches 3 does not exist. So we have a discontinuity here. And this type of discontinuity is referred to as an asymptotic or asymptotic discontinuity. This also is an example of an asymptotic discontinuity. It is readily seen here that this function is not defined for x equal 3. As x values approach 3 from the left, f of x grows without bound. As x values approach 3 from the right, f of x grows without bound. That's what we have here. F of 3 is also undefined in this case. Note that in this particular case, even though the limit is not defined, does not exist, it is acceptable that you write it this way. You can say that the limit of f of x as x approaches 3 is plus infinity. Just remember that infinity is undefined. So we probably are at about the 10-minute mark. So I'll have to close this video here and continue this topic in a next one. But before I go, I'd like to summarize these 3 types of discontinuities. We have point, gap, and asymptotic. One way to visualize whether or not a function has discontinuities or not is to see if you can draw that function without having to lift your hand. If you can draw that function in a given interval without having to lift your hand, the function is continuous in that interval. If you have to lift up your hand for whatever reason, then there is a discontinuity right there where you have to lift up your hand. Okay, so we'll close out this video right here, and we'll continue with this very same topic in the next one.